Welcome to HEAP, Harrison's Engineering Aeronautic Project, or hey, look at that flaming heap on the ground. Uh, Interesting enough, nothing has caught fire yet, despite my very shady soldering and wiring. So that's good so far. So the objective of HEAP was to design and build a fixed-wing drone. The problem being gravity, the plan to build a drone with the correct weight, lift, and power ratio. Easier said than done, I found out. It cost about $300, mostly in electronic equipment for like the motors, the transmitter, and the receivers. So I almost a year ago, I had planned to divide and organize my work in the timeline you see before you. Although that did not pan out as expected, and it was more like that. Funny enough, I had not learned my lesson the second time around, and my winter schedule followed a fairly similar pattern. My original design had 6 servos, 2 motors pushing the plane forward, and a dual fuselage system. And then below that is a diagram of the servo control surface relationship, basically how the servos would pull the flaps and ailerons. I went to Mr. Wilson with my design. He noted a few complications or things I might want to change. One thing was I pushed the center of gravity forward. He suggested I reduce it to 4 servos for simplicity's sake. So I removed the elevators, basically having the ailerons do both the work of the elevators and the ailerons. So I used the website and YouTube channel Flite Test for a lot of parts and ideas. I bought all my electronics off them because they sold a lot of the stuff I needed in packs that I knew were compatible with each other. And I found it extremely difficult to figure out what needed to go with what when piecing it together myself. And I also watched a lot of their build videos to get an idea on how to build the plane as well as what to make it out of. They do a lot of foam board kits, which is what I eventually went with. I learned some useful properties of aerodynamics and aerospace. One being the V-shaped wing. It helps planes fly level, as when the plane tips to one side or the other, the lift force on the lower wing increases as it tips, equalizing it, as shown here. A misconception I had about airplane design was that the center of gravity was in the center of the plane, and the forward wing and the aft wing both created a lifting force. This is incorrect. I learned that the center of gravity is 4 of the main wing, which produces the lift, and the aft stabilizer actually produced a downward force when flying level to balance out the forward center of gravity, almost like a seesaw. And the way this is advantageous is when the plane tips downward or upward, the stabilizer will produce a greater downward force or a lifting force depending on the orientation of the plane, as seen here. So I, at the same time as I was learning these, I did a materials test. So I made this kind of glider just to get used to working with the foam board. And I then proceeded to check it off my roof, and I kind of sketched the flight path on the graph below. This is a good and also a bad flight path. Good in the form that it shows that the plane did create lift with the wing surfaces. A bad that it was too tail heavy and it stalled at the fourth point and then fell and nosedived. That is a bad flight path. It's better to have a slightly nose heavy plane. It's like easier to fly, and yeah. So I adjusted the model. I brought the wings back farther, and I taped a bunch of dominoes to the front to bring the center of gravity forward. I have a materials test here, which I would have passed around if we were not doing this virtually. And I also tilted the aft stabilizer downward slightly. It's hard to tell, but right there. Next, I made a 3D model to help visualize my project even further, just to keep reiterating on the design. I made it in Tinkercad. This version had 5 servos. By connecting the rudders by a line in between them, so I could use 1 servo for both rudders. Then in the build model, I went with 4 servos by putting 1 rudder in the middle of the plane and then having the elevator being 1 long control surface throughout the back. The problem with this build was that the motors that I had acquired were too weak for this size of a plane, and it was not able to move fast enough to create lift. Over the winter, in my last presentation, I proposed that for the winter term, I would, after getting new electronics, I would create a launch and capture system that was essentially a slingshot and then just a wire to grab onto to capture, very similar to a aircraft carrier. This design was heavily inspired by the company Zipline, which uses drones to supply medical equipment like blood in Rwanda and Ghana, where roads are inaccessible. I said this in the last presentation, and then while driving home, I realized I could either spend $100 on getting all new electronics, or I could go the cheaper way of making a much smaller plane. I went with a smaller plane design. My revised drone had, I was going to build 2 of the smaller drones since I had 2 motors, and I could use 2 of the servos for a V tail, and the servos would be able to act as all 3, like aileron, rudder, and elevator. But the problem I realized was I only have 1 receiver, which is what the controller talks to in the plane. And also, I didn't quite know how to reconfigure the receiver to take all the inputs from the controller and transmit them to the same 2 servos to do all the different tasks required of it. So for my final revision, I added another servo, bringing back a separate ailerons and an elevator. But I did not bring back the rudder, as I thought for simplicity's sake, it would be easier to leave it off, and it's not exactly necessary with a drone this size, because turning can be done just by banking and pulling up. So for this design, I went with a more simplistic version. So the first flight test did not go well. It's probably not hard to notice that it is extremely nose heavy. The wings were basically just flat poster board that I was hoping would do the job. It did not. And so I adjusted this. I flew it again. I crashed it, but I forgot to take a video. So this was a revision I made to it. I uh, added another smaller layer of poster board on top, then wrapped paper around it to make a more airfoil shape that actually creates lift, which is something you need for a drone. When I flew it, it did fly for a bit, but I crashed it, and it broke the engine plate, which was now 2 balsa boards because I broke the 1 balsa board plate on the last video you saw. And then I had a realization. Early planes were all biplanes until about halfway through World War I. They started producing monoplanes. So before that, they had planes like the Fokker DR-1 for the Germans. So I decided what I needed was to add another wing. So I added a second wing under. I did the same design with the paper over to create an airfoil, and I used the dowel to create struts to hold the wings together and hopefully not break as easily. With the wing under, it made it much easier to stow the battery and the receiver without having to tape everything down. It just kind of held nicely in place. And I flew it. Now, that does not seem like a success at first. After multiple viewings, it may not seem like a success. But the reason for this crash was not mechanical error, but pilot error. I have learned that I cannot fly an RC plane. So if you look closely, the plane flew straight until the elevator was pushed down by me, fearing that the plane would stall going at like it would not have enough power and it would just kind of fall out of the sky. So I pushed the elevator down, and I severely underestimated the amount of control authority the elevator had, which is also a good thing, sort of, because it shows that the plane is able to respond a lot better than I assumed it would to the controls and the control surfaces. I just can't fly it. So it flew in a straight path until I forced it downward, and it again broke the now 3-plate thick balsa plate that I had the engine mounted to it. And at this point, I was out of balsa and hot glue. So, but I had not realized that the engine plate had broken until my second flight, where it spun out because the engine was now tilted to one side, so it dragged the whole plane in a death spiral. Yes, so here I have the biplane and battery, and so the way as like a physical demonstration that I would have done in front of everyone and passed it around, I will now do through virtual. I've got the controller here, and basically how you control the plane is hello? I think.
No, you're still good. I just made you bigger.
Okay, sorry.
So you're not sharing your screen anymore, so we can see you.
Okay. So the transmitter or the controller sends a signal to the receiver, which then with use of the battery, sends a signal to the servos that are then connected to the control surface. So when I move the controller, it moves the servos, which moves the control surface. As a quick demonstration on how the control surfaces of the plane work, and then also another wire goes to the throttle, obviously. Quick note, there is supposed to be a plastic kind of cap on the front of the propeller, but due to me, one, not realizing that the way I connect the motor changes the direction that the motor spins, and trying to figure out which propeller to put on, and then being confused when I reconnect the motor and it spins a different way, caused many of the plastic caps to fly off. So now I kind of have it hot glued on. And so another note is these batteries have not been charged since the fall, because I had been planning on recharging them shortly before performing my latest test flights, but I forgot that the only charger that I could use was at school, and I obviously couldn't go back and charge it now because Corona. So I also have here with me the cannibalized parts of the original build, like the wing, the fuselages, and the stabilizer and rudder. Although they're a bit destroyed, I wanted to talk about how my design changed going from the big to the small. For the big drone, I wanted to make everything almost as loose as possible. So I had the wing attached to the fuselages by rubber bands, and dowels through the fuselages. And the front of the fuselage is just paper in a bent, slightly aerodynamic shape. A lot of these design choices were made to, also including the idea of having the engines pushing the plane instead of pulling like a traditional plane. All these decisions were made to basically, I wasn't expecting to be a flying ace the first time, and I expected to crash it many times. This design was chosen to help the plane fall apart easier without anything breaking. So the engine or the wings would fly off before anything actually snapped. And the front is basically just a bumper of paper that I could easily replace. Now, moving to my smaller design, with a smaller plane, I didn't have to worry about strong torque forces as much because there's less leverage to actually like rip something off. As you see, it did take a bit of a hit here, and it's completely fine, except for the engine plate, which has repeatedly cracked. And if I were to rebuild this, I would add more diagonal struts to the balsa wood to reinforce it even more, hopefully finally. Another thing that I had realized was after building my first design, I really should have built, or should have gotten some professional kit or a professional RC plane to build before trying to build one all on my own, so I would know what works before seeing everything that doesn't work. And so I went with the forward-facing engine again, and the general design was basically supposed to be just as simplistic and standard as possible, not trying anything too like advanced or dramatic, because as proven by the common design of most planes, this works, whereas this is not as common and works less often. So, oh, and because of a lot of comments on the lack of landing gear on my first drone, I added some skids to the bottom of this one. And that is my HEAP. Thank you.
Harrison, really good job. That was I was incredibly engaged, and your PowerPoint was. I love the animations. I had no idea about the V shape of the wings. It does make, when you showed that, it makes a ton of sense. Does, you kind of mentioned it, but about halfway through I was wondering. So you had the propellers at the back of the plane on your first build, and then your final design has it at the front. Does it matter which way it goes around, clockwise or counterclockwise, or is it how the actual propeller is bent, what direction it's bent?
It mostly has to do with the direction the propeller is bent. The kit I bought with the motors and everything, it came with 2 sets of propellers. One had, there's numbers that are kind of hard to read. One had an R on it, and since it had 2 motors, I didn't know if that meant right or reverse.
Mm-hmm.
So I did a lot of experimentation to figure out which propeller was actually supposed to go on what, and because I didn't notice that the 3 unmarked wires that connect the motor, if you change the order in which those are connected, that changes the direction. I was very confused many times when the propeller I thought I had tested was for some reason pushing the plane backwards. But so when I chose the reverse push, that was in expectance that I would nosedive a lot, which would save the motor and whatever it was mounted to, which is a problem I did face multiple times with this design.
Mm-hmm.
But I decided to go with this due to just stability of the plane. Having the weight forward is a lot easier done when the engine is forward or the motor is forward, because the 2 things that are the heaviest are the battery and the motor.
Mm-hmm.
So for stability and weight reasons, I put it forward and paid the price in balsa wood and hot glue.
So
well, first off, that was really fun to watch, Harrison. I love your graphics. And I do want to take exception to something. I disagree with you on one thing. I think it was better you didn't do an RC kit. The amount of trial and error that you demonstrated, I think you would have lost had all the answers just been handed to you. It would have been a lot less frustrating and a lot quicker, I agree, but man, you learned a lot. The V, when you went to the bonanza shaped V tail, was it a question of it got too complex because the tail then had to be your rudder and your elevator, or why didn't you stick with the V design?
It like was a bit of, well, for a bit of the complexity of how to rewire, reprogram it, which I didn't exactly understand, or and also only having 1 receiver, so I wouldn't and transmitter, so we wouldn't be able to fly both at once. And if I couldn't fly them both at once, why not just make one good one instead of two meh ones? So, but the way a receiver works is you have different channels that the servos and the motors plug into. So the first one is for the battery. The second one is for the motor. That goes like ailerons, elevator, rudder, and then you can add different things for like extendable landing gear, or like if you want to have your plane like drop a payload, you can have all sorts of stuff with the remainders. But
when you sewed the servo with the ailerons, were they counter turning so you had no yaw?
Yeah, so in the V-tail design, they would both turn one way at the same time to be able to have some yaw. It would also control it would also pitch the plane, or not pitch, tilt the plane at the same time. But it's sometimes like some prototype planes have used this design in like some gliders. But I decided it would be better to have a 3-servo plane that I knew I could do, instead of trying to figure out how I could connect all three of the required outputs to the same 2 servos, and how like I could get to do exactly what I wanted to do with the so like pushing this way on the plane actually made it turn that way. But yeah.
And did it affect the plane's turning ability by having your ailerons close to the fuselage as opposed to out on the wings?
It did not like sorry, excuse me. It's not overly affected that much with the difference. It was better for the leverage of the servos, since the servos are mounted in the side of the plane, to have as much of a parallel line with the arm and the control surface to get the most leverage possible with the control surface.
This is a good job. This is well done.
Very good job. Anyone
Thank
else
you.
have questions? Lucas?
Are you gonna put the motor back into it and try to fly it again?
I probably will, just on my own time. Yeah.
I want to be there. Yeah, let me know how it goes.
I don't necessarily have to be there. I just want to wear a helmet.
All right. Harrison, well done. Very, very, your presentation was awesome.
Yeah, excellent job, Harry.
I thought I don't know if you built those animations or if that was built into, I don't think you, what did you use? Not PowerPoint. What did you use? Keynote?
Keynote.
They made your presentation. And then your ability to just talk off the top of your head about all this stuff, I think is, to Mr. Mead's point, your trial and error paid off more than I think you'll ever know. So I'm glad, I would echo that I'm glad you didn't buy a kit before, because I think you learned a lot more and you were able to explain it to, I don't know, Mr. Mead looks like he's had some experience in this stuff, but I'm a total amateur when it comes to this. So the fact that I was able to understand everything and have a bunch of aha moments, you should take that as a giant compliment.
Thank you. And a lot of my ability
it's funny, while you were presenting, Harrison, my notes, I wrote, does he try the Bonanza V-tail and how did it go? And literally, that's right when you went into it. But I still don't, I understand why you put the ailerons next to the fuselage for the leverage of your salvos, but that has to make for a very, you're not maximizing the, the distance on the wings. Because if you look at regular airplanes, the ailerons are right at the tip of the wings. So it must have been sluggish, or it had to have changed it's fascinating what you did. Do you have to worry about yaw with such a small drone, or is it just mostly lifting and turning?
Well, at one point, when I still had it as a, actually, you can kind of see it in one of the, like the first video, as I throw the drone, it turned to one side here as it spiraled. So yes, and I found surprisingly that adding the second wing kind of fixed that problem, strangely.
And did you set the wing? They're not parallel to each other, are they?
They are. Well,
So
there's a little bit of a bow in them, but yeah.
No, but when you go from the dowlings, is it straight up, or is it like a biplane? The top wing will be a shade ahead of the lower wing.
Oh, yeah, it's
yeah.
Actually, that's the kind. Yeah.
Why is that?
It's for like aerodynamic purposes. It helps with the uninterrupted airflow, I believe.
Oh,
Yeah, if you have them completely parallel, the I think it's the bottom wing will stall much quicker. Yeah. It messes up the airflow.
Yeah, because the air can't get above it, probably.
Yeah.
As well.
Harrison, it's really God. I am so glad you did not use a kit, because they just would have gone right to you wouldn't have learned any of this stuff. This is terrific. This is great.
Even if
glad you didn't build it to be in it.
Yeah.
Oh, yeah. So for my materials test, I went with the V-wing, which did make it fly straight. But as you can see, with the obscene amounts of duct tape around the wing, it was hard to get it to keep that shape.
Yeah.
So I eventually went with that, with a more sturdy, just flat wing design, sacrificing the stability, but keeping structural integrity.
Well, I think it was very smart on your part. I don't know if you figured it out beforehand or somebody told you to build your bigger prototype in such a way that if you crashed, things would fall off as opposed to snap. Was that because you lost some pieces, or did you think of that up front?
I thought of that up front with my very limited time actually flying RC planes. I mean, like when I was little, I had one, but like a couple of years ago, my uncle and my grandpa are like really into RC planes. One of them, or they're both pilots. One of them is a commercial pilot, so that's like most of what they talk about. And they were flying a plane at one of their houses, and I asked if I could fly. I immediately flew it into a tree over the lake, which only came down like next year in a storm. After my grandfather had already bought a second one. But yeah. So I was well aware of my lacking in the actual piloting skills. So I intended to build around it.
It's great. It's bravo.
Great job. You're the third or fourth guy throughout these presentations who's learned something other than what they set out to learn too. So
Thank you.
great job. All right. I'm gonna. Any last Any last questions before I stop recording?
I just wanted to add, great job. I really, really enjoyed that. And Harrison, I think you did really, really wonderful job. Just echoing what everybody else said.
Thank you.